All right, we're moving right along here. Now we are ready for Chapter 3. Chapter 3 gets to those areas that some of you have had questions on, units and prefixes. What are these prefixes all about? Well, we're going to find out how we use prefixes instead of exponents and vice versa. They become very handy tools for electronic engineers. So we're going to look at the units, prefixes, how we convert back and forth, its applications, and any systems in measurements. We're going to learn to convert numbers to engineering notation, very valuable tool. Apply the various prefixes used in the electronics field. Convert from one prefix to another. How to affix correctly the prefix to electronic or electrical quantities. Use of the calculator. When we're dealing with engineering notation, apply various prefixes used in the metric system and convert between English and metric systems measurements. If you've been playing with your calculator, hopefully you've seen that your calculator does a lot of those conversions already built in to the calculator. Very, very, very handy. I'm playing with it and learning more about that very powerful calculator, that Casio, that we've suggested that you purchase for this course and future. So units. Well, in the prefixes that we use that relate to powers of 10, in engineering notation, we typically use factors of 3. So you can see down here, 10 to the third, 6, 9, 12, 10 to the minus third, minus 6, minus 9, and 12 are all values that we use to calculate shortcut notation with electrical engineering. So instead of saying 10 to the third, we say K or kilo. 10 to the sixth, meg or mega. 10 to the ninth, gig or giga. 10 to the 12th, tera. 10 to the minus third, milli. 10 to the minus sixth, micro. 10 to the minus ninth, nano. And 10 to the minus 12th, pico. A lot of these metric values ought to be very familiar with any of you if you're computer geeks, because you use these metrics all the time in the speed of your computer, the amount of data, the amount of storage, the many, many factors in your computer applications. So, Rule 3.1, if we make exponents more positive, the decimal point moves to the left. We can change the number using powers of 10. So we've seen this before. Okay, you should have this down by now. Okay, a lot of these examples are things that and values and conversions that we've already looked at. It's just a rehash here. What we're trying to get to is the use of those exponents in the metric prefix applications. Okay? So let's take a look here. More examples. Work these examples out. You can see how we are using the value and then the exponential, the value and then the corresponding exponential to get to those metric values that are so valuable in electronic engineering. 10 to the minus fourth, not a value within electronic engineering. 10 to the minus 6, micro, very valuable in electronic engineering. So we start applying these prefixes for the exponents. 10 to the 6, mega. 10 to the minus 4th, we change to 10 to the minus 6, move the decimal point, and we have what essentially becomes a milli value. 10 to the minus 4th amps, move the decimal point even further over, we get 10 to the minus 6 micro. So it's a matter of learning how to use those values in different applications. You can see for standard SI electrical units, Systems International units, for capacitance, current, energy, impedance, reactance, time, wavelength, we all have symbols that we attach to them. We prefix them with these values of K, M, N, P, the little funny looking U for micro. Okay, here are our values. All the way up to 10 to the 18th, exa. Right now, tera, 10 to the 12th. That's the size of hard drives and memory space today. The next step will be up to peta. You'll start getting peta values of your hard drives. So you can see the shortcut symbol that we use for each of these, as well as the power of 10 associated with it. So we get used to changing numbers to match the prefixes in our electronic measures. Okay, so it's that little micro becomes 10 to the minus 6, and if you want to express it in long form, there it is there. Okay, so example here, how do we change from 10 milliamps to 10 microamps? Well, we just add places to it. 20 milliamps equals 20,000 microamps. Okay. 450 microamps becomes 0.45 milliamps. Okay, so all of these prefix changes. Okay, when we come back, we're going to take a look at some applications because this involves some math and we need to slow down and really take a look at what we're doing here because this becomes a very powerful tool when dealing with combining things like resistors and changing between conductance and resistance.